Well, good afternoon, everyone. Welcome to session 21 for Track C. Very pleased to have a very special speaker this afternoon, David Salvagnini. He's the Chief Data Officer for NASA, and his topic he's going to discuss with us today is value creation at NASA, a new CDO's perspective. With that, I'll turn it over to you, David.
Thank you very much. Good afternoon, everyone. As I was thinking about this presentation today, have you ever been to one of those meetings where, you all sit in a circle and there's maybe 30 people? And, some facilitator invariably will say, okay, starting with you, one word, tell me what you think about this session today. And I'm the last guy, right? And you're out of words by then, right? It's like what they all said. So I'm thinking to myself, well, here it is, late Thursday. What could I possibly say as a CDO with 6 weeks tenure at NASA that could be new and exciting for you guys? So we'll see whether I'm successful at doing that or not. The other thing I'll tell you, the dirty secret is the person who hired me at NASA, I found out I was selected for the position. I don't remember exactly when. Let's just say it was early May. About a week or two later, I get an email that says, hey, and by the way, we signed you up to speak at the CDOIQ conference in Cambridge. So, oh, okay. But nevertheless, what I didn't want to do is I didn't want to take the position and kind of say, I don't think I'm ready for that. So hopefully I am. I am a prior CDO. I came out of the intelligence community, if you read my bio. Basically, since 2001, I've been supporting the intelligence community. I was a CDO at the Defense Intelligence Agency. My last role was actually at the Office of the Director of National Intelligence, where I was a chief architect under the ICCIO, working very closely with the ICCDO on sort of data architectures and common data services for the intelligence community. So I'm going to get you started with something just to get us thinking about the organization, and then we'll dive into the topic. So let's go to the video, please. Yeah, just make it full size and bring up the audio. And there should be sound too. And maybe restart it. Thank you. Thank you. Back to the slides. And next slide when you get a chance. How many people in the room knew that NASA was flying helicopters on Mars? Okay, maybe a third. I actually didn't know that before I joined NASA, but what's really cool about that video, as they get it sort of get us back to the slides, is this defines NASA. It's basically charting into the unknown, trailblazing, doing things that had yet been done before, and pushing the envelope. Pushing the envelope to support discovery and our understanding of our universe. And we'll talk a lot more about some of what NASA does. But think about the data that enabled that to happen, right? So you would say to yourself, well, wow, that's a pretty amazing organization that is able to understand its data in such a way that it can actually do something that had never been done before. The atmosphere on Mars is quite different than the atmosphere on Earth. How do you even test that? That satellite, or that helicopter, by the way, was built largely with commercial off-the-shelf pieces. But the rotor blades are a lot larger than you would have to have on Earth because of the differences in the atmosphere, the weight. The first flight, I think, or one of the early flights, was about 90 minutes long. Pretty impressive. It has since flown more than 50 flights. In fact, more recently, they lost control of it. Because what happened was they flew it, and it landed on the other side of sort of a ridge line. And the way that we communicate with that helicopter is through the rover, right? So the rover is a relay. So when it landed on the other side of a ridge line, they basically couldn't communicate any longer, communication line of sight. So they had to move the rover, right? Reestablish communication. And then the concern is dust on the solar panel, because you can obviously get to the point where you're no longer able to recharge and rejuvenate the power pack. So very interesting work. Lots of data that contributed to that type of success. Lots of data at NASA that contributes to many other mission successes across the organization. Let's go to the next slide. Actually, you want to go to the one after the one with the rover, with the helicopter on it. Next slide after that. Okay, this is what we'll talk about today. I'm going to talk a little bit about NASA's strategic foundation, the data journey at NASA, and I'll dive into sort of our data strategies just so you have an awareness of kind of what we're thinking. I will say, we're probably not going to say much in the data strategy that you may not have already heard. We'll talk about culture a fair bit. We'll talk about our digital transformation. And what I'll do is I'll do a traceability of our transformation and our data strategy. One of the other things as I was thinking about this opportunity, and they called me and offered me the job, one of the appeals is that NASA has a very active digital transformation activity going on, and data is an integral part of that, and you'll see that later in the presentation. That to me was quite appealing. The fact that, okay, it's not just CDO to fill a square because the Evidence Act says a federal agency has to have a CDO. It's actually that you mean something here, that you're trying to actually do something for the good of the agency, and I thought that was quite compelling. We'll talk about open science and my observations, and then I'll give you some ways in which you can engage with some of the data that NASA produces for the public good. Next slide, please. Oh, by the way, this image, can you go back one? I'm sorry. Yeah, so this is one of our areas of pursuit is earth science. Okay, so this is an image that, interestingly enough, shows two hurricanes, Brett and Cindy, that were out in the Atlantic at a period of time. But you also see the smoke, okay, basically working its way across North America and across the Atlantic from the fires that are unfortunately occurring in North America. So we feed a lot of data to support climate science and earth science activities. Next.
So is that an integrated image, an image over an image? Because there's no satellite that far away from the Earth to do that one.
It's another space-based. I don't know if that came from the ISS. I could find out. But it's another space-based sensor, yes. Yep. Next slide. Okay, so let's talk about the NASA strategic plan, and we'll talk about the data strategy. So what's really interesting about the NASA strategic plan is you'll see a couple of key things here that I touched on in the helicopter video. Pushing the envelope, exploration, innovation, but for the benefit of humanity. So NASA is not about itself, it's about the good of the collective, the benefit of humanity. And therefore, our mandate is to share our data. Share our data for the good of humanity, for the good of scientific exploration, and also to share our data to basically help develop commercialization around various different discoveries and innovations that NASA has been responsible for building and developing. And then you'll see in our vision for the benefit of all. I won't spend a lot of time on the data strategy, but you see some key themes here that collaborate, learn, share data. We have something called FAIRest, which we'll talk about a little bit later. It's basically FAIR with a URT at the end. So we'll chat about that. Basically unleash the full power of data. This could be anyone's data mission, data vision. So let's go to the next slide. This is just a little bit more, if you don't know about NASA, just to ground what NASA's about. So if you look at this is the strategic foundation for NASA. The things that you'll see on the far left, those are sort of enduring themes. These are things that if you looked at the NASA strategy 10 years from now, you're going to see this. This is basically the identity of what NASA does: discover, explore, innovate, and advance. The things in the middle, this is about a 10-year horizon. So one of the big flagship activities right now is Artemis, going back to the moon. Why would you go back to the moon? Well, you think about the technology that's available to us today, 50 years later, to collect information about the moon and things beyond the moon is far more superior to what we had during the Apollo era. So we're going back to the moon. We're also going to be establishing a presence on the moon, which is really a critical pivot point for deeper space exploration. Innovation and the development of economy. There is a lot of research at NASA that goes into aerospace industry. So we're looking at, for example, accelerated aircraft that are able to travel at supersonic speeds without creating a sonic boom. Okay, so think about that a little bit. Also, how you optimize your airspace management infrastructure. So there's a lot of research that feeds the aviation industry and the aeronautics industry. And of course, advancing capabilities for the good of humanity. You'll see data in 1.3 there, but really data is part of everything. I did a search before I joined NASA of this document, and I found how many times does data reappear as a theme across the document. And it was something like 378 times. And I didn't mean it wasn't superficial. I mean, it was embedded in every part of the organization, whether it was an HR organization, whether it was an acquisition organization, or whether it was a mission organization. So I found that to be compelling as well. They get it. They understand the value of data. I was at an intelligence organization, and I did the same search on our strategy, and I don't think I found the word data. Yes. I don't know, maybe they probably used intelligence instead of data, but nevertheless, I thought that was actually quite interesting that the organization understands the importance of data and is basically it's interwoven in every part of the organization. Next slide. Oh, I'm supposed to do this. Okay, see, new guy, that's a rookie mistake there. All right, here's the journey, right? I won't spend a lot of time on this because really it's about here and now. It's not about the past. But if you're familiar with how the government does this, or we had something called the Evidence Act. What the Evidence Act did in the 2018 timeframe, and it said federal agencies have to identify a CDO, a Chief Statistical Officer, an evidence officer, things of that nature, because we want to drive evidence-based decision making, right? So the commercial sector doesn't have that, academia doesn't have that, but the federal government does. And I would say it's a good thing because there are statutory authorities that come along with that. I often equate the Evidence Act for CDOs as similar to Klinger-Cohen for CIOs. It establishes the authorities that a CDO has within an organization. And they're quite clear. What is a CDO's responsibilities? What is the role, et cetera? They actually did a nice job with that. Moving along, what we did is we responded with putting in place governance. We hired our first CDO. We started looking at standards. We integrated with the Federal CDO Council, which is a good group of folks. And we built out our data strategy. And we published our data strategy in the 2021 timeframe. We also published a geospatial data strategy. So NASA is authoritative for geospatial data. There's actually another law that talks about, it's called the Geospatial Data Act, which also requires federal agencies to have a senior geospatial official. And now there's an executive order that basically says agencies are supposed to have a responsible artificial intelligence official as well. So we have a data governance board. Now there's a key theme here. You'll note here, we charted and ratified in this period, and then something happened here. The data governance board combined with the IT strategy board. How many people think that's a good idea? Yeah, I don't either. But why did that happen? Well, it's a symptom, right? So what happened was I think they were looking at the meatiness of topics being addressed at the data governance board and said, it's not generating the value for the investment, so therefore we're just going to make it an IT thing. One of the things I haven't investigated yet that I look to investigate in the not too distant future is how many topics since the DGB got stood up have they actually addressed meaningful topics? What are the statistics? It's all about measures, right? And I would say, and I was making a comment last night with some of our colleagues in the room, said, there are so many data topics at NASA, I could probably fill the agenda for a year and still not have enough capacity to address them all. So if the fact is that this now being collapsed into the IT strategy board and there are no topics of substance being addressed there because the IT strategy board is going to be focused on probably IT things, I would say that's a bit of a problem. All right, next slide. That's me. I learn fast, right? Just took, halfway through the presentation. Okay, strategic pillars. So if you read the strategy, okay, you'll find these are sort of the themes within our strategy. Strengthen. This is really about governance. This is about stewardship. This is really about the network of data professionals that are going to work on behalf of NASA to advance that strategic agenda. The data strategy, but I would say it's not really the data strategy, it's the NASA strategy. Because if data is interwoven throughout NASA's organizational strategy, then really that's what I'm enabling. The data strategy is because we had to have one. And you could almost have a one-pager that says, hey, we're going to do what the NASA strategy actually wants us to do. But nevertheless, this is the network of professionals that are going to enable that, and this is sort of the structure that's going to enable that as well. Data-driven culture. This is really about the workforce and the culture, and how do you deal with that? So part of our digital transformation activity you'll find is that we have a lot of data courseware available. One of the other areas I haven't had a chance to dive into is what's the metrics on the utilization of that courseware? How many people are taking courses? What is the transcript look like for the various different data professionals across the organization? So another consideration for me in the not too distant future. So that's advanced. We have something called a one data culture. Okay, so we're thinking about, one authoritative source of data, themes that everyone is really wrestling with. Build. So build is really more about secure hosting capability and sort of an environment, if you will. Think about, we have a program called the Enterprise Data Platform. So what we look to do there is create the environment that enables some of the work that needs to be done to get done. Now, that's not to say that the scientific community doesn't have an environment. Of course they do. But there are parts of the organization that don't. So the HR department, for example, may not. The Equal Opportunity Office may not. The logistics team may not. So basically creating that environment for those who have not been able to create one for themselves is part of sort of the build capability, and making sure the critical ingredients, the critical pieces are part of that environment, that platform. Things like catalog, search, visualization. Also creating a consolidation point so that we don't have to rehost the same data over and over and over again, and basically have a drift in the authoritative nature of some of those data references. And then improve. And this is where that FAIRest thing that I talked about, and what that is findable, usable, interoperable, reusable, FAIR. We all know what that is. That's kind of a common acronym that's very well published, very well written about. But we added understandable, secure, and trustworthy. We do have security concerns at NASA, although we share a lot of data. There is also a lot of intellectual property rights sensitivity around some of the systems work that we do. So as such, we have to be very careful about, yes, share, but also protect the intellectual property of the United States, because obviously there are people who are quite good at, if we make it publicly available, leveraging it for their own interests. So then, so we have these themes. Then we talk about, the operating model. So strategy, operating model, platform. These are sort of what we're referring to as design intents at NASA. We already talked about the strategy, so I won't go into that a lot. The operating model really now is how do we operationalize the strategy? How do we start doing what we said we would do? And really that gets to the outreach across the organization, which has occurred, but I would say it needs to occur again. Outreach for me is quite different than I think maybe outreach is for others. Outreach, I think before, was something on the order of, we think we have the right answer for you, here it is. Outreach for me is, what are your pain points and how can I be of help? How can I be a strategic partner with you? How can I basically help you solve some nagging problems? How can I help you understand what your critical data sets are for your mission effectiveness? And how can I help you manage those critical data sets in a way that is, going to result in good data and good outcomes in the end? And then the platform, which is really talking about that capability that I talked about, the enterprise data platform. It's interesting, I will say again, another observation. By the way, the opinions expressed here are not necessarily those of the organization. So I'm thinking I'm in somewhat of an academic environment. So again, I'm giving you sort of my candid personal views of what I see as someone who is an experienced CDO from elsewhere and a senior, an experienced architect as well. But I've seen the intelligence community try to go down the path of, I'm going to build this big thing, and you're going to put all your data into it, and it's going to be beautiful. But it doesn't work. It doesn't work. And why doesn't it work? Well, maybe if I'm a business, and maybe if my product lines are very nicely aligned to each other, and maybe if the transactional work that I do around planning for those product lines, delivering those product lines, et cetera, there's a lot of similarity. Maybe that works for that scenario. It doesn't work for an organization like NASA, and it doesn't work, clearly doesn't work for the intelligence community because, again, very diverse mission sets and very nuanced differences in the kind of data that's collected. I mean, the EDP doesn't know how to deal with space-based data. Think about things like time. We think about time, okay, well, what's a standard time if we have a global enterprise? Well, we would say GMT, Zulu time, right? What is time in space? Well, there's a whole different standard for time and space. And systems have to be able to deal with that, right? Coordinates. I remember this in the intelligence community. Okay, well, are they minutes, seconds, minutes, hours, or is it decimal? Right, so that's easy. But what are coordinates in space? Quite different, right? So your systems have to be able to deal with the dimensionality of the data, and oftentimes programs, if they're not purpose-built for that, and the engineers and the scientists that are working with the data, they expect a different visualization experience than a business analyst would expect. So very nuanced differences in the data, very diverse mission sets. Therefore, one solution does not fit all. A little bit more on the data-centric enablers. Let me see how we're doing on time here. They asked me when I was being considered for the position, of all the elements in the data strategy, what did I think was the most important? And I thought it was a trick question because it's like, well, gosh, they're all important. I wonder what they think the right answer is, because I certainly want to tell them what they think the right answer is. But I took a leap and I said it's really the workforce piece. It's about the culture. And I think I was right. They must have thought I was right too. So this slide sort of gets a little bit more into that. This is really about the stewardship, but really about the behaviors around stewardship. And I would share a couple things there. Does a steward know what a steward is? And do they know when they show up as a steward or get anointed as a steward, what that means to them in their in their day-to-day activities? In some cases, the answer is yes. In some cases, the answer is no. And in some cases, we've thrown this term at them, and they don't know what to do with it, right? So then we say, well, we got to train you. We got to make you a steward. But I would argue that the stewards exist. There are people that are incredibly good at stewarding data within organizations before we ever called them stewards. Otherwise, we would never get anything done, quite candidly, right? And we get a lot done. So someone is doing something right somewhere. But nevertheless, we have these roles, and I think one of the things we have to accomplish in this sort of governance model and in kind of dealing with the culture is creating clarity of purpose of all of these different data roles across the organization. Even think about the CDO. So I have a colleague in the Science Mission Directorate. His duty title is CSDO, Chief Science Data Officer. Right? I would offer that there probably needs to be, maybe the titling has to be different, but probably multiple CDOs, right? The Manned Space Flight Mission Directorate basically needs a CDO, very unique, very domain specific. The Science Mission Directorate needs a CDO. But then what is the enterprise CDO? And how does that get stitched together? So what we have to do is really have to noodle through these roles and start to think about, okay, who's doing what where, and obviously make it complementary across the organization with an appreciation for the very unique differences of how a CSDO shows up and does their work compared to, let's say, the CDO-like person or persona that sits in the Mission Support Directorate that's responsible for things like HR, finance, contracts, and logistics. Upskilling, reskilling. This is, of course, an important part of the journey. And again, you can't know how to upskill or reskill unless you understand what the role is. So basically, in the service, I'm retired Air Force, we used to call it duty position qualification. Well, you have to duty position qualify the role of these various different data workers, and then you have to equip them with the appropriate knowledge, training, so that they can effectively perform what they need to perform in that role, so they understand what's expected of them. And then the technology, which really gets to all of these attributes, the findable, accessible, interoperable, reusable, understandable, secure, and trustworthy. It's a nice acronym, but it is foundational to, okay, how do we discover data? I'll give you an example of a breakdown in data stewardship. So I was looking at a search engine. And the search engine happened to hold a corpus of data from, let's say, 1980 to current. And I said, okay, let me do a search, see how this works. And it returned 250,000 results. I thought, wow, this is great. 250, this is. And I got really kind of curious and said, well, I wonder, what if I narrow the search down to 2023 only? I wonder what that would reveal. And it revealed, let's say, 200,000 results. So total set 250,000, down to 200,000 for 7 months. I thought to myself, wow, I mean, we're contributing a lot of content to this, to this corpus, and the engine is, allowing me to find this stuff. This is really cool. Well, the dirty secret is that date published was not part of the results. It's almost like they were talking earlier about a company where they had social security numbers embedded in the last name. A data consistency problem. Well, in this particular case, we didn't have the published date, so that's interesting. I also didn't know who the author was for a lot of the. So that's data stewardship, and that's a symptom of a problem, a gap. The thing about NASA, an amazing organization. So please don't get me wrong. That's just sort of an example of how bad things can be sometimes if you're not doing the kind of things you need to do to steward the data. We're a systems engineering heavy organization, okay, which means the people process stuff tends to sometimes, take a back seat. Unless you're an astronaut and you're preparing for, an EV, a spacewalk, then of course that's rehearsed to a high degree, but that's a very high risk operation. So managing this particular corpus of data wasn't going to get anyone hurt. So it wasn't given the time and attention it needed. So now what do I do as a CDO? Well, I can highlight that and say, this is why we need data stewardship. This is why we need people curating this data in such a way that it is in fact findable and our search return, our discovery abilities are accurate. Let's go to the next slide. Oh, gosh, man, how quickly we forget, right? It's all the pressure I'm under. How many people are we up to? I told him earlier, I said, if we break 120, between online and in a room, that's my threshold. I'm just going to fall apart. Oh, I got a little bit. Oh, God, I'm right at the edge. All right. Let's see. Does anyone have any questions before I go into this?
We have a question online.
Okay.
How does profiling of unstructured data work at NASA? What's the split in terms of volume between structured and unstructured data?
Oh, my goodness. The split between structured and unstructured data. Could anyone answer that at any organization? I mean, oh, my goodness. I'm the CDO? Yeah, I should have that answer. I'll get right on that. The split of unstructured and so, I would argue that if a space-based sensor is going out and pushing, and by the way, operational missions, so our science mission director is the largest producer of data in NASA. Okay, that's basically all of the deep space exploration platforms and all the things that sit in various forms of orbit, as well as the climate research platforms and such. We're at a petabyte level of collect on a day-to-day basis. So I would offer that's likely a good blend of structured and unstructured data. To what extent, I'm not sure. What was the other part of the question?
How much it's all about the unstructured.
Right. I mean, typically when you have a sensor pushing data, I would say there's a pretty sophisticated data model. So one could make the case that it's very structured data. But I wouldn't begin to know how to find that answer, to be honest. And if I had the answer, I'm not sure. I mean, it would be interesting to know. So I don't mean to trivialize the question. Any other questions in the room? Yes, in the back there. Oh, how about right here? She's closer. And then we'll get to him. Work smart, not hard, right?
Sorry. When all these machines or satellites or whatever is there in space go to space, how do you prepare whatever is in there, because I have no idea, the software or the cameras or whatever, to, when they capture information, to do it in a way that afterwards it's easier for you to understand the data?
Yeah, so, honestly, that's a very domain-specific question that I wish I had the answer for. If you were and it's specific to different missions, right? Mm-hmm. If you're a heliophysicist and you're actually dealing with the platform that is doing deep exploration and looking at the sun, that's going to look quite different than, let's say, a more recent platform that was put in orbit that's looking at the composition of the atmosphere from the perspective of pollutants over North America. So these are very, very specifically built data models to support a particular scientific experiment, if you will, or research activity. So I know that's not there's not a single answer. I mean, it's very sort of platform specific. And I don't know that maybe the CSDO has that answer, but certainly the Enterprise CDO at NASA does not, at least with 6 weeks tenure. There was another question in the back.
Good afternoon, Gilles from MIT. You've got a lot of research data. We've got a lot of research data. You're just saying petabytes of data per day that you're receiving. My question is about the retirement of that data. Do you keep it forever, or do you have also like some policies, particularly on the research side, about how do you manage this large amount of data?
Yes, and this was a challenge in the intelligence community, as you can imagine, as well. And people like to keep their data forever. So when a mission is started, when a engineering activity is underway, they're required to submit a data management plan. And the data management plan looks at the data model, the details of that particular platform, and how that data is going to be collected, what the model is, where the interface is, where it's going to be stored, and then ultimately how it's going to be processed through to archival or retirement. So that's a requirement so that you understand life cycle costs. I mean, you can't just be collecting petabytes of data and have a runaway train from a cost perspective. So I would say those details are embedded in those data management plans. And again, very specific to the mission, very specific to the platform. Does that answer your question? So any other questions before we move on?
So in terms of the role of the CDO and what you do, how much of that is today's at NASA's internal, where you are doing data governance and platforms for different mission teams, versus like external, where you're sharing data products with the ecosystem of partners and like SpaceX or whoever is out there, right?
Yeah, so we're going to actually get into this a little bit here because we have an open science initiative where we're working extensively with partners, not only international partners, but academic institutions and other research institutions as well. And we do work very closely with those institutions. Has anyone heard of the mission OSIRIS-REx? OSIRIS-REx is it's a platform that was launched in 2016. Basically, it's a space-based mission that landed on an asteroid. It landed on an asteroid called Bennu. And what it did is it landed on that asteroid and it took samples from the asteroid, and it now is bringing those samples back to Earth for analysis. They were very, very selective in this particular asteroid selection because of its orbit and because the potential that it could reveal things about our universe that other asteroids might not be able to reveal. Why do I bring this up? That sample is due to return to Earth in September this year. If you look at the research plan, well, where is all of that going? It's going to about 200 institutions. It's a collaboration of international partners and academic institutions. Publicly available information, if you look at OSIRIS-REx on the NASA site, you'll actually find the diagram that shows where all of those samples are going to go and who's going to contribute to what parts of the analysis of that information. So that, I think, is an example of very deliberate collaboration with partners. Recognizing, of course, that different partners have different strengths in their ability to achieve outcomes in that particular endeavor. Does that answer your question? Okay. So I'm kind of teetering on this slide here. So open science. So 2023 is the year of open science at NASA. It's actually the year of open science across the federal government, and you see other institutions doing this work as well. DOE, for example, NOAA, and others, which means that we're publicly sharing our scientific data. We're publicly sharing our algorithms, okay, to be able to get the citizen scientists involved in our work. And of course, there's great strength in doing this, but there's a couple of key things here. Open from start to finish, transparency, community involvement, broadening community involvement for the sake of, scientific discovery, getting outcomes that you may not have otherwise gotten if you kept it within. Accessibility of data for publications and inclusion. This is huge, by the way. I was talking about this last night with some colleagues. Scientists, we all have a network, a professional network. I have people I went to college with. I have people I've done research with and other, activities. And therefore, I feel very comfortable kind of bringing them into my research activity. But that doesn't necessarily mean that we're not, are we making the data equally available to, let's say, underserved populations in that? So, we endeavor to do that. When we talk about open science, we're really talking about equitability, for the good of the mission, but also for the good of the population at large. Next slide. And there'll be some references, by the way, on open science where you can actually get to some of the search engines and you can discover some of our data. And I actually have something, I'd be interested in hearing from people what they think of the readiness of our data to support not only discoverability, but maybe some deeper research with that data. We can go to the next slide. This is the open science data in action slide here. This basically is a representation of the corpus of holdings, point-in-time snapshot, of course, and a link to the URL. So if you want to get to this, this is where you can find this information. By the way, NASA is also a massive contributor to GitHub. So a lot of the code that's used, because one of the other things we want is repeatability. So if scientists comes up with an outcome based on a set of data that they've analyzed, we want to make sure that other scientists are able to repeat those results because that's important validation. Next slide. Okay, so let's talk about digital transformation for a little bit. As I was telling you, my colleague, my partner in crime at NASA is the Chief Digital Transformation Officer. And quite honestly, I was impressed that, and I've learned that other organizations that represented or spoke here also have Chief Digital Transformation Officers, which is fantastic. But I was just quite excited to hear that NASA made that investment. A senior executive who is given that role. And by the way, the CDO, the Chief Digital Transformation Officer, her name is Jill Marlowe. We are actually sort of in an interesting role. We're nested in the CIO. Some people have asked, hey, where are you aligned? And is that problematic or not? We're nested in the CIO, but we actually are referred to as sort of ALOs, agency level offices. So we function as an agency level office, which means, okay, sort of CIO is sort of our holding place. It's our administrative support thing, but it doesn't restrict us in any way from going out and doing the work that we need to do. Okay, so the digital transformation framework, what I'll talk about here is this is all, we haven't talked about technology yet at all up to here. Everything here is about the business. So you see things like work, workforce, workplace. Let me just refer to something here so I don't forget some key points. Think about transform the way we work. This could manifest itself in a digital assistant. So you have a researcher who's working with a digital assistant to augment their work and basically deal with the scale of information that they may be working with. You deal with the way we work. You deal with someone in NASA who maybe has an opportunity to contribute to a mission area that they wouldn't ordinarily contribute to. Maybe someone who is in the finance department but gets to do a special project in a mission directorate and get really excited about the mission in NASA. NASA is 10 years in a row voted best place to work in the U.S. federal government. The reason for that is people are excited about the mission. Right? So then if you kind of silo them in a part of the organization that is sort of doing mission support work, well, you can say, well, yeah, I'm part of the mission. But it's really nice to give people an opportunity if they're curious and willing to actually more directly participate in that. So, and then transform the agility of the workforce, the ability to be able to work faster, because think about the pace at which decisions are going to have to be made, the pace at which data is being presented to us, and how are we going to scale. How many people feel overwhelmed with the amount of data that comes at them every single day in the work environment? I mean, okay, so not that many raise their hand, but I would say probably many were very shy to raise their hand. The reality is we are bombarded. I mean, we're in a data-abundant environment, and it's going to continue to change, right? So how do we basically deal with that? How do we make quicker decisions informed by that data, which means basically we have to be able to pull the tidbits, the value out of that data faster. So, they used to talk about needle in a haystack. Well, the haystack's getting bigger, right? So, and then there's targets. So we have 3 goals, really focused on people. Then we have targets, transform engineering. Think about how we engineer systems today and how we need to engineer systems in the future. Fundamentally shifting to more of a model-based approach to engineering. I mean, NASA is an amazing organization, but it's also a government agency, so it has some bureaucracy, as you can imagine, as any government agency does. And thinking about how do we get a little bit more agile about how we do our engineering and reinventing that discipline. Transforming discovery really is about that mission, right? So basically, if the focus is discovery, it's how do we get those platforms deployed and available faster. So that's really the engineering to enable the discovery. Discovery, an interesting comment was made recently at NASA about some of the platforms that we deploy. Platforms are outliving their life expectancy significantly. So there's this thought of, okay, you launch something into space and it continues to kind of go out and explore. Well, how do you equip it to continue to explore generations beyond, what you might have imagined, and thinking about, how can AI help that? So if you think about an IoT model and you think about, okay, how do I do AI at the edge and pre-process a lot of data and ship back some findings? There's some interesting use cases there that are being explored. The discovery feeds governance and transform the discovery feeds data. Data is how we transform decision making. And we talk about this. This is not the CDO by itself. This is the whole of NASA at large. So when you think about digital transformation, don't think about, CIO, CDO by themselves. This is every part of NASA thinking in these terms. Okay, so it's a whole of agency approach to digitally transforming the organization, not just a CDO, CIO kind of a thing. That's when I said ALO, agency level office, that's really what's meant. And transform operations, and this is just our ability to continue to make decisions faster and optimize, right? Because everyone is interested in efficiency, so optimizing the business, if you will. The levers, architecture, processes, this is where data is. So this is where it gets exciting for me, because there I am, and then if you decompose what's meant on the data side, it's the things that they're asking me to do are quite appropriate for what you would expect a CDO to do. So I am a critical element in the digital transformation process as the Chief Data Officer, as would be the network of other people who support me in that role, right? Whether they be stewards or others. And we're talking here about discoverability, but also the readiness of data to enable the faster decision making that needs to be made. When I talk about that corpus of data and having a search result that's defective because, metadata is not properly populated, we got to fix that. And when we digitally transform, part of our endeavor, part of my job will be to come up with ways to institutionalize that and do it in a more consistent manner. Common tools. NASA is a very decentralized organization. So if you think about innovative organizations, that's a strength. Decentralization is a strength. Okay, but it can also be a liability, right? Because what that means is that every organization kind of figures out their own way of doing things. So what we have to do is we have to fine tune what is that sweet spot. Where is there a lot of autonomy that's specific to mission, but where are there common services where basically that autonomy can be enabled through the consumption of some common services so that everyone doesn't have to create every piece of the tech stack or the data stack that they're using to be able to get to the outcomes. And then, of course, you see inclusive teaming, which is, again, getting at how we do work. And then these foundations, this is really some of where the technology is. Zero trust, if you're not in the U.S. government or in the U.S., I would say, I think it's global. Zero trust is a big deal for us. So we have mandates to pursue zero trust in our architectures end to end. There are 7 pillars. Some would say there are 5. Data is one of them. But basically, this is going to be a big deal, certainly for us as chief data officers in the federal space, because what we have to do is if the metadata doesn't allow me to know the data document was published, how do I secure it? Right? I mean, date published is kind of basic, right? So, now let's say if I have sensitivity levels around how I have to handle that data, whether it's contractual sensitive, personnel sensitive, a whole host of other things. So we have to get this right. And zero trust is a model that assumes a penetration has occurred and minimizes an adversary's ability to laterally move across the environment and do damage. Okay, so data, of course, is an important part of that, as well as identity and a whole host of other things. So I could probably, my last job, I did a lot of work on zero trust. Let's go to the next slide. So I'm the chief data officer. I made this slide. The other slide was from the digital transformation officer. And of course, I had to make data the middle of everything and the biggest cog in the wheel. But I do believe that that's the case, right? And I would offer, because what isn't enabled by data? I don't know, if someone wants to challenge me and say, now granted, all the other things are important as well, but I believe that, the data piece is huge from so many perspectives. Next. Okay, observations. Are there any questions before I share some of this? keep saying next slide. Gosh. All right. Okay, let's go through these then. I already talked about the digital transformation officer having a keen appreciation for the role of data in the organization. I talked about the NASA strategy, not the data strategy, the NASA strategy, and the prominence of data in that document. So the appreciation across the organization that data is a critical asset. So I don't have to talk about data is the new bacon, or data is the new oil, or data is the new currency, or any of that other stuff, because we get that, right? Now I just have to realize. I have to realize value. I have to basically turn words into action. So, authorities. So I talked about in the federal government, we have the Evidence Act, we have Data Act, we have a whole bunch of things in statute that say, hey, there has to be a CDO, and the CDO has to do these things. But the way that works in the federal government is you have to have a policy framework. So you have to translate statutory language into a policy within an organization, and then those policies sort of get translated into regulations and operating procedures. So at NASA, that's a gap. So I have a statute, and then I have kind of a void, right? So I have to fix the void, right? Only because kind of like federal and state, right? The organization has to interpret the statutory language in terms that are applicable to the agency. So that's something that I have to do that has yet to be done. And by the way, I don't know that I can do governance. Now, I was talking after one of the sessions 2 days ago with the CDO from Visa. I think it's Bob. Probably getting his name wrong, and I apologize to him if I am. But nevertheless, I said, well, governance, and his angle was, well, you just get the right people in the room and you make a decision. Well, I mean, that sounds pretty agile. I like that. But, in our world, people, well, you don't have the authority to make that decision, because people can be a little territorial sometimes, perhaps in the private sector space as well. Private sector, I would imagine everything stops at the CEO, right? So, you have a way to resolve things. At NASA, it's not quite that simple. So it's important that we have the policy framework in place to enable governance, because governance is really about making decisions, right? And it's kind of like, well, who has the authority to make the decisions? I have a charter that says the CDO is the chair of the data governance board. Well, I was when there was a data governance board that wasn't any ITSB. But that in and of itself is not enough, right? Do I have the authority to write a policy and make it binding within NASA? Well, right now, the statute says I do, but there's nothing at NASA that says I do. So we've got to, that's something that I have to deal with. It may or may not be applicable in some of your roles. Clarity of roles. I talked about this a little bit earlier, but understanding all of those people who have a role in data, stewards, custodians, practitioners, et cetera, data scientists, data engineers, data modelers. And what are those roles? How do they complement each other? And if there's a hierarchy involved in all of this, what does that start to look like? If there's a CDO and a CDO-like person in these directorates, what does that look like as well? And what do I do versus, let's say, what does the CSDO and the Science Mission Directorate do, the Chief Science Data Officer? Maturing the network of data stewards once you have clarity of purpose, I think is important. Being able to move faster is also important. Data-centric versus system-centric architectures. Again, I talked to you a little bit about NASA being a very technology-heavy organization. If the only tool in your toolkit is a hammer, every problem looks like a nail, right? That's how the expression goes. So, every problem looks like a systems engineering challenge, when in many cases they may not actually be that. So, really kind of changing that paradigm, which really gets to culture, right? That's just an organizational behavior, and hence culture repeated 3 times. I talked about alignment a little bit. I talked about resources. One of the things, and I'm kind of curious what you guys think of this, is my final interview stage before I accepted the position. My boss says to me, "Well, what do you think about joining an organization where you have no people and no authority, but all the responsibility to do this job?" And I thought about it for a moment. I said, I think it's okay to start. You know, if I get in and I do a good job, you know, it's going to become very clear what is going to be needed. And I'm not looking to build an empire, you know, and if I make the case successfully, I'll get the support I need. I mean, you're obviously committed to accomplishing what we're trying to accomplish at NASA. It's written in the NASA strategy that's signed out by the administrator. It's not your document, it's your boss's document. So, I mean, I think the mandate is there. The statute says, you know, CDOs can have a lot of authority. So we'll figure it out. So I was okay. It was okay. And he committed to me that, you know, the reality is we're gonna make sure you're successful. So I just have to build the case for if there is resourcing required and anything else that I might need that I can get it. And I'm not going to ask for, you know, 30 people, you know, overnight or something crazy like that. The last thing I want to say is the example earlier about search results and about 250,000 versus 200,000 findings, and the fact that published date was just not a metadata tag that was consistently applied. None of this stuff that CDOs need to do happens by accident. It's got to be very deliberate, which means it takes a lot of resiliency by the CDO and a lot of drive by the CDO to kind of force the changes that need to be made across the organization, really driving at that sort of culture piece and addressing really the behaviors that are not enabling us to be fair or fairest or whatever it is we're trying to accomplish with our data. So I've included, when you get these slides, a whole bunch of links to how you can get to our catalog, how you can go to our API portal, how you can get to the Earth Science Search, Science Data Engine. So there's a whole host of resources here. I would offer to you, if you have feedback on what your interaction, what your experience is with any of these resources, I would be welcome to hearing your feedback. One of the things I need to do as a CDO is hear from people. Okay, how are we doing? You know, how usable is our data to support some of what we endeavor to accomplish? There's an app. This is kind of cool if you're a space geek or not. And are there any other questions?
There's time for a couple of questions, I think. We do have one online. It's kind of complicated. Regarding
Probably come from NASA.
and engagement of citizen science, is the goal just to open and share the data, or provide guidance along with it as to what NASA's research priorities and goals?
Absolutely.
Yeah.
Right. No, that's a great question. So what we do is we solicit proposals from citizen scientists on various different topics. So it's not unstructured. It's not, contribute by chance. There's actually a call. There's a prioritized research list that's well curated across NASA, and then people have an opportunity to propose. And by the way, when they propose, they actually have to submit a data management plan. So if they're going to come up with conclusions as a result of using NASA data, they basically have to share. If they've aggregated data and created a data set to support their conclusion, they've got to have a way of managing that, how that's going to be, what that data model looks like, and how it's going to be handled throughout the life of the project. Any other questions?
Time for one more.
Thank you. Maybe less of a data question, but I wanted to go back to your point about the inclusion aspect of the open science program. It's something that a lot of agencies are trying to figure out how to do one way or another, but obviously we're being a science-based, research-based organization. There's a lot of potential there. How are you going about achieving this, though? Other than just saying, we got to go beyond my own networks. What's that look like?
I take your point. So I think what you're really hinting at or poking at there is the fact that creating a search engine and saying you're about, inclusion and accessibility doesn't necessarily make it so, right? So how do we measure that? And I don't know that I have a good answer. Even understanding utilization statistics against some of those search engines and who's pulling the data, how often it's pulled, by whom, et cetera. I mean, one of the opportunity spaces I see early is how do I start to measure the data operation? Where data is going, where it's, to whom, at what volume levels, understanding those transactions. So I take your point. I think it's a work in progress. Quite candidly, if we're true to what we say we are, then we need to be measuring, and we need to put measures in place. And I would say so our chief statistical officer gets challenges from OMB, and he often has. That would be one of the areas that I know that he is having to build evidence around. Just like, how are we increasing the proficiency of the NASA workforce around sort of data skills. So it's a good question.
Well, Dave, it's a great presentation, and I appreciate you taking the time to share this.
Yeah, thank you very much. If I didn't blow it today, maybe they'll invite me back and I can tell